In this setup here, which is commonly called a Atwood's machine, we have two blocks, 11 kilogram and 7 kilogram. Both of them, of course, are going to experience the Earth's gravitational pull downwards. The 11 kilogram will experience a pull of 11g, the 7 kilogram, 7g. Both of them are also going to experience the upward pull of the tension in the string. Under perfect conditions, the tension at both ends of the string should be equal in magnitude. So these two tensions are equal in magnitude. I think it's fairly obvious that everybody knows this setup here is going to accelerate this way. The heavier block here is going to accelerate downwards, whereas the lighter block is going to accelerate upward. If we assume that the string is totally inextensible, it must mean that both blocks must move by the same amount all the time. If one block moves more than the other block, it must mean that the length of the string must either become longer or shorter. So if you assume that the string is inextensible, it must mean that the acceleration of both blocks are exactly the same. They're just in different directions. So to answer the first part, the tension in the string must be smaller than 11g. If you consider the 11 kilogram block, we know that the net force acting on this block must be downward since it's going to accelerate downward. So the tension in the string must be smaller than the downward 11g. If the tension is not smaller than 11g, the block is not going to accelerate downwards, it's going to accelerate upward. On the other hand, the tension must be larger than 7g here. It must be larger so that this block here experiences an upward net force, resulting in an upward acceleration. In the next part, we are supposed to calculate the tension in the string. To do that, we simply have to apply Newton's second law on the 11 kilogram block and then on the 7 kilogram block separately. So for the 11 kilogram block, since the acceleration is downward, we are going to take the downward 11g minus the upward tension and equate it to the 11 kilogram times its acceleration. We do the same for the 7 kilogram block. For the 7 kilogram block, the acceleration is upward. So we take the upward tension minus the downward gravitational pull and we equate it to the 7 kilograms block's mass times its acceleration. And the rest is mathematics. So we have two equations here, equation 1 and equation 2. So we add the two equations together so that we can eliminate tension first. So from here we figure out that the acceleration is 0.222g. This makes sense because if the 7 kilogram block wasn't here, then the acceleration would have been just 9.81 because the 11 kilogram block would have been free falling. But because of this 7 kilogram block here, it doesn't free fall. It accelerates downward, but with a smaller acceleration than g. After that, we just have to substitute the value of a into equation 2, and we can obtain the tension to be 83.9 newtons. So this is just another example of the application of Newton's second law. On the left hand side, just collect all the forces acting on the body, and on the right hand side, just write down the body's mass and its acceleration. Easy. And thank you for using XM Physics.